Hello, my name is Elena and this is the second video in the series Apache Kafka Simply Explained. You can find the link to the previous video above or below in the description. In the last episode, we gave the definition to Apache Kafka and looked at where the need for Apache Kafka is coming from. Let's move on and to understand how Apache Kafka works and how we can work with Apache Kafka effectively, we need to talk about Kafka's way of thinking about data. The approach which Kafka takes is simple but quite clever. Instead of working with data in the form of static objects or final facts, final information which is aggregated and stored in a database, Kafka deals with the entities described by continuously arriving events. So in our example, for the e-commerce project, we have a list of goods that we sell. Their availability and other characteristics can be presented in a table in a database as numbers. For example, we can say how many donuts are right now available in our shop, how many glasses we sold, and so on. And this gives us some information, some valuable final compressed results. However, in case if we want to get some more data about the sell trends, demand, peak search times, we should have planned this in advance. We cannot deduct this information from what we already stored in the database because anything that is stored there is a compressed snapshot, one-dimensional view, or we can think of it as a single dot on the infinite timeline. What if instead we can view this data as a flow of events? For example, a customer ordered a tie. Another customer searched for a donut. Then the previous customer, we dispatched the tie to that customer, and the second customer decided to order 5 donuts. And this shows the whole life cycle of a product purchase. Instead of seeing the single data point, we observe the change of state, we can replace the events, we can start from the start, we can move to a certain point of time. We can't change any of the events, they already happened, but we can kind of relive the events again and again, calculating metrics we need, answering different types of questions about the products and sales. And this picture is way more complex. But instead of giving us flat final numbers, it gives us this 360-degree on the data and plenty of possibilities. We can answer all kind of questions later in time without planning this in advance. This type of architecture is actually called event-driven architecture. Many of you might be familiar already with it. But let's look at how Kafka works with event-driven architecture, how it works with data feed. So we have Apache Kafka cluster. I put it here in the middle, and in the central area we'll see what happens inside the cluster. And on the left and on the right you'll see how other applications interact with the cluster. Apache Kafka coordinates data movements and takes care of arriving messages. It uses a push-pull model to work with the messages. This means that on one side we have structures that create and push the messages into the cluster. They're called producers. And these are applications that you write. And on the other side, we have consumers, which pull and read the messages and do whatever you need to do with that information. Again, consumers are the modules you write and control. You can have as many producers and consumers as you need. In our example, for example, the producers can be part of the front-end applications, web and mobile apps, observing user actions, packaging that information and sending events to the cluster. And consumers can be connected to the subsystems responsible for notifications, deliveries, recommendations. Consumers are hardworking apps that read messages one by one, processing that information, taking what is needed. Producers and consumers can be written in different languages, different platforms, completely not knowing about each other's existence. And this is how Apache Kafka helps decoupling our front-end app in this example from other microservices. They just don't need to know about each other. They only need to know about the Kafka cluster. What is more, we can shut down some of the producers, and other producers that will be sending events to the cluster will continue working, and the consumers will not care that the messages were produced by some other entity. They wouldn't even realize that. There is no synchronization expected between the work of producers and consumers. They work at their own pace and their own convenience. Consumers also can get broken, but producers will continue working without issues. Once the consumer is restored, it will pick up where it left off because, as we mentioned, the records are persistently stored in the cluster. So now that we know where the messages are coming from and who later reads them, but how are they organized inside the Kafka cluster? Let's zoom in and see what is happening there. A set of events that come from one by one from some kind of a source we call in Apache Kafka a topic. A topic is an abstract term, and we'll come back to this later, but let's say it's not how stuff is stored on the disk, but rather how we think of it to simplify things. You can have as many topics as you need. They can be compared to tables and database, so this one can be product related stuff, describing states of product sales, what was searched, ordered, delivered. Other topic can be related to a new user registration, and another one can contain application events about any errors, warning, or current health state. The data is continuously flowing into that topic. There is no pauses, no breaks. As long as our application is working, we have new users registering, new products being purchased. The messages within a topic are ordered. Each message has a sequence number which is known as offset, and this number uniquely identifies the position of the record. There is a bit of complexity which comes to that, and we'll come back to that when we will be discussing partitions. But for now, remember that we have this number offset. The messages are also immutable, so you cannot really change them later. And this kind of logical. Think of it. When some event happened, someone bought a donut. You can't really go back in time and change that fact. Unless you're Michael J. Fox and you have a DeLorean. But otherwise, if you don't like donut, you have to throw it away. But technically, this is a new event. Also, you can see the topic as a queue, but here is a twist. In Apache Kafka, unlike in many other queue systems, the consumed messages are not removed from the queue and not destroyed. Instead, they can be read by multiple consumers multiple times if needed. In fact, it's pretty common scenario. Information from a topic will be used by multiple consuming applications for different needs, approaching data from different perspectives, because as we said, when working with events, we have this 360 view on our data. And now that we have covered a bit about the topic, consumer and producer, time to create these elements with the code using Java. And this is exactly what we are going to do in the next episode. See you there!